So week 5 already. It's amazing. Okay. We're going to do 64, 65, and 66 as our wake our brains up at the beginning of the week after the weekend review. And 64 we did as we were having people come into class. They asked about that one. So it's the same. Brenda has 3 problems. Zane has 3 problems. And your random homework list does the same kind of thing if you go up to wherever that is. But the random homework just breaks it up into more steps. So there we go. Okay, so we're doing Zane's. So he has an annual income of $65,000 and he wants to spend 30% of that on a mortgage. So don't fall in the trap. Yes, to find 30% of a number you would multiply by 0.3, but that's the whole year, right? Because his salary is an annual salary. So to find out how much he wants per month for a mortgage, you'd then take that number and divide by 12. So he gets $1,625 each month. And as we mentioned again and again, this is his whole budget. So we'll see that he's actually going to pay less than that and talk again about why for the reporting. Then there's 2 numbers on the table, 15 years and 5%. So we go back to the amortization table, look those up, $7.91. And then every time he goes to the bank with his suitcase full of $1,625, hands $7.91 to the teller, he gets $1,000 of loan. So he can play that game until he runs out of $7.91 packets. And he could do that 205 times. Everyone behind him in line at the bank is impatient. He gets $205,000 of loan. Okay, we'll leave that up because people are writing. Let's actually look at the homework, just because it's kind of spread out on the page differently. So Clementine can afford a monthly payment of so-and-so. We don't have to do the 30% and divide by 12 kind of business. It just gives us that number. She wants a 25-year loan, 7%. We would go back to the table, see what that number is. Oh, scroll nicely. There we go. So we would look at that table. Might as well put that in the slideshow. And so 25, 7%, 25, 7%, $7.07. So how large a home is affordable? So we would take her monthly budget, divide it by the $7.07. We get 106. Each of those is 1,000, so 106,000. So same thing we just did with Zane, but with the formatting on the homework page. So that looks nice when you see it at home. Okay, back to Zane. So now he actually will get a loan It has a 15% down payment, and let's just go with that much only for now. So down payment so 15% will be 0.15 with a RIPLOP. His loan amount was $205,000. So we multiply by the 205,000. 30,750. Everyone's calculator gets that too. So I will write the word down payment again. So then his actual loan typo. 174. Okay, so now we know what his actual loan is, and we need that before going on, so it was okay that we sort of stopped where we were. In the random homework, then it breaks that out as a next step. So just the down payment part, stop the paragraph, multiply by the percentage, and then you subtract it away from the actual loan size. We could, at this point, also find the new monthly payment. So let's go ahead and do that now for Zane also. So we take how much the actual loan is, the 174,250, divide it by 1,000. So we get 174.25. That's how many thousands of loan he's actually getting. Zane's table value was 791. So his actual monthly payment to the bank will be, oh come on, make a big dot, the $1,378.32. He budgeted $1,625. So we have two numbers for his monthly payment. But again, that's fine. This is how much he's paying back the bank for the loan of the $174,250. He probably doesn't have the $30,750 down payment just sitting in a bank account doing nothing. So he's going to be borrowing that from family, from friends, from his retirement fund, from his kids' college fund, whatever. And he has to repay back those other sources of down payment. So that's where his extra budget monthly expense will go to. Okay, now let's finish this problem. Make another copy of that. So 4% fee. 4%, 0.04. His actual mortgage, 174,250. the first month prepaid we just did. 1,378.32. How can I round that? 1,378. Good enough. So add all those up.
You had the down payment too?
Oh yeah, I forgot that. Okay. Yeah. That was what? 37.50. Thank you. Okay, now add these all up. So 39,228, is that what everyone gets? I must have done a typo. Yeah, 43.90. Okay, everyone happy? I'll come back if you want, but again, for this one, they're broken up. Fee amount is this, and it doesn't ask for the rest. It's just a random. Grab that, go back to here. Okay, anyone need more time on this slide? Okay, holler if you do. Oh, that one we did already. Okay. Let's see. Previous slide.
Can we do 61, do it backwards, no
Can we do this one? Sure.
I was going to use myself in my field backwards or whatever.
So we have the 30 years and 5%. So we go to the table. 30 years, 5%. We get $5.36 as the number. So we need to say every time she pays $5.36, she gets $1,000. How many times can she do that? That's a division problem. So it's about 168,000. Remember, we used the table twice. The first time you're dividing, you're saying, how many times does the table number fit into a big number? The other time you're multiplying, because later on you'll say, the smaller actual bank part of this budgeting process is the 174,250. So that's 174.25 thousandths. Each of those is going to cost the table amount. So each of them costing that amount is a multiplier. Okay, all good questions and review. Any questions on the bell curves homework? We did a bunch of them, if not all of them already, but I should still ask. If not, it will be due a week from today, because this is the first class no one had questions on. Any questions on other homework things? Okay. So time-wise, we're on track. We're about to start the saving for retirement section. And it's up to you. I don't know what your other classes are doing in life and jobs and things. Do you want to do a midterm that doesn't count for anything but practice sooner or later? Should we do it like a week from today? Or should we wait till after we're done with the saving for retirement?
I'd like to go through the material before I do it, my personal choice.
So not halfway in the term, but just later on. Okay. Email me if you're shy and don't like that. Don't want to say it.
Makes more sense, I think, waiting till after we're done with the next section and then take a quiz on it.
So it'll be a first 2/3 of the class midterm, not a half of the week's midterm.
And that we'll be able to like write out our like notes or whatever.
Yep.
Can it be like more than one page? Can it be like a note card? Is it like
No, it should be a big, should be a nice bunch of notes, not just a page or a card. Again, the goal of this class is that you will have some notes that make sense to you, because my website might change and look different 5 years from now, right? And so that later on in life, when someone says, how big a house can I afford? Then you can say, wait a minute, back in Math 25 I did that, and go to your bookshelf and pull this out and solve that kind of problem. And so, yes, your notes should be pretty thorough and complete. They can have practice tests in them. They could have homework in them. But if they're too big, then they're bulky, and you will spend all your time flipping and searching while everyone else in the room is doing math. So the main thing that the practice test does, why it is worth doing even though it's not graded, is that it lets you see how your notes are serving you. Are they doing a good job? Are they doing a medium job? Are they doing a lousy job? And everyone will touch up their notes in some way or another after giving them a dress rehearsal.
Is it okay if we have like example problems on those?
You should. Again, the only way that the midterm matters for your grade is there is achievement at the bottom of, where is it? After the midterm, turn in a detailed study plan. So, I learned I'm good at this and this and this. I need to fix up my notes on this and this topic, and I really need to study more of this one, and so on. A study plan should have both what to study and how you're going to study. So how will you study the thing? I'm going to, whatever, make flashcards, or do a study group, or work with the person in my house who's good at this kind of thing, or find some videos online, or whatever works for you. So then you can get a check mark. Okay. Backing up again, the health decisions were kind of simple things. Here's lots of formulas. It's pretty obvious which formula to use when. Plug the numbers in, get the results. Hooray! The personal finance decisions were trickier. The typicality, just the English was vague. What does it mean that something is representative? The bell curves, you could change the shape of a curve with the different bins at the bottom and so on. So you can kind of fudge your answers, purposefully or not. The mortgages is a little tricky because there were just so many little steps. And some things like the monthly payment, there was 2 different monthly payments, one in the beginning and one towards the end, and so on. So that was a little confusing. It was a process, not just a formula you plug in numbers. The saving for retirement is tricky because there are 3 formulas we'll use: simple interest, compound interest, and sum of annuity due. And you need to know when to use each one. And in some problems, you'll have to use more than one, and you'll have to know which part of the problem. Part A is this formula, part B is that formula, and so on. So the choice of which formula to use will become tricky for the first time. Eventually. We might not get that far today. In fact, I would be surprised if we did. Of all the little subtopics that are cute little pictures and boxes, this is by far the longest one. So mortgages we spent 3 class days on, 2.5 so far. So saving for retirement, we might do like 5 class days if we need it. That's fine. We are not in a rush. The business decisions are back to kind of smaller, quicker things after this. Yes?
I don't know about everyone else, but personally, it would help me if I had the formulas before we begin. Do you mind going over that before you begin the thing? Or the 3 formulas?
I'm just going to give you them one at a time. I want to do some preparatory work also, which will look a little familiar. So in our Math 20 review, then we talked about percent sentences already. As always, I'm not going to read the cute quotations during class time. Go back and look at this on your own. So the percent sentences we've talked about before. Is that blue better, by the way? I can't remember if I changed the blue from... I've changed the blue. That looks better on the board. Projector colors. Anyway, so we talked about these before when we were doing Math 20 review. Now we actually need them in Math 25. So we're going to go over them again. If I am going too slow or too fast, let me know. So a percent sentence is a short word problem that includes the words is, of, what, and percent in any order. And what we will see is that when you have a word problem about percents, then you can translate it into a short percent sentence to help solve it. So currently, it is flu season. There are, 100,000 people in this city, and 80 of them have received their flu shot. How many have a flu shot? Then you could just translate what is 80% of 100,000. Get rid of all the extra stuff in the word problem. So these are something to know how to do, but they're also a tool for how to do more complicated things. So here are 3 sample ones. What is 35% of 60? 12 is what percent of 5? 5 is 2% of what? Yes?
I use a power formula, part, whole, and rates. So take out the vowels and you have the word power. So 35% of 60 would be percentage, and 60 is the whole, so it'd be bottom, so it times each other. So 0.35 times 60 is.
Okay. Try that for all 3. Make sure it works well. And I will go back. The 2 things I'm going to teach, and we can have Edwin show us his on the board too, it works for all 3. Is the translate and the proportion method. We've talked about these in review, but again, I'm going to pretend that you were absent that day or something, because it's been a while. So if you want to translate to solve percent sentences, you use the normal things you do for word problems. Of is multiply, is means equals, what is your letter, and I always use y. I have it says the textbook. In Math 20, the textbook uses the word percent becomes something, but don't do that. Riplop is much easier. So let's do these 3 with the translate method. Good here, yes. So what becomes our letter? Is becomes equals. For 35%, well, we're going to have to riplop. We're going out of percent, so to the left. Of becomes times. And we get 21. Everyone okay with that easiest example? Okay. Okay, someone who hasn't done 4 things up at the board. Anyone want to come up and do this one? You? Okay.
Okay. This one is different. Okay, so is I don't know how to go backwards on this. Can I see my notes real fast?
Sure.
Okay, so y equals.
Don't jump ahead. So to take each thing, just go kind of left to right and turn it into the other thing. The second on the top is your undo arrow. There you go. So 12 stays at 12.
Divide?
What is begun?
I have is means equals, so
Equals,
just
yeah.
equal. What is the variable?
You're squishing. So undo the equals, put it right under the is. There you go. Put the y right on. Yep.
Equals y. Multiply. I don't know what you would multiply. Just y times 5?
Yep. Uh, 12 is y times 1.
Okay. And so then I divide. Oh wait, no. Yeah, divide.
Yep. Okay, so 2.4 is good as a number amount, but why it asked us to express it as a percentage. So since it wants the answer in percent format, we need to do a riplop.
20. Yeah, it would be 240.
Yep.
Oh, wow, that one was so hard for me.
Good luck. Okay, I'm going to erase this little zero, make that look a little nicer. Just for when people look to this at week 10. So we were going right into percent, so that was to the right twice. Okay, everyone okay with both of those on the board before we go on to the third one?
I'm just gonna write down the steps really fast. I'm almost done. Okay, I'm good.
Then we had is 2% of what? Okay, is it back to my turn or does someone else want to do it? Okay, back to my turn. So 5 stays 5, is becomes equals 2%. Going left out of percent. We need to divide both sides by 0.02. We get 250. So when I do this process, there's always a riplop. Maybe a number started in percent format, and as I translate, I will take it out of percent format. Or maybe, like on Amanda's one, the answer needs to be in percent format. So there's no riplop at the beginning, but at the end I have to riplop to get the percent I'm looking for. So that's the translate method. There's also the proportion method. The proportion method has these 4 steps, which won't mean anything to you if I just read them out loud. So let's use them on the 4 things, or 3 problems, I'm sorry. Here's our 3 problems. Here's our 4 steps. Okay, so what is 35%? $60. So my first step is to write the skeleton of the proportion. Fraction bar equals fraction bar. My next step is make the right ratio represent a percent with something over 100. So in my problem, the percent is 35%. When I do the proportion method, which I should label, I suppose, there's never a riplop because we always have a fraction with 100 as the denominator instead. Okay, the next step, the bottom left is whatever follows the word of. The English would sound funny if of was the last word in the phrase. There's always something after the of. So whatever comes after the of goes in the bottom left. And then lastly, there's something that I haven't used yet. In this case, it's the y. Okay, can I grab just those? No. Okay. Everyone okay with my 4 setup thing? 4 parts. Some people will be taught to memorize a phrase is over of, but that's not always true. The thing in the top left doesn't always have an is associated with it, but the of is always the bottom. Okay, now I have a proportion. The reason people like this is that they like proportions. So y times 100 is one diagonal. 60 times 35 is another. Is it okay that I'm not making my circly loops? We've done enough cross multiplying this term. I can make loops if you want. Okay, so y times 100. So 60 times 35. Oh, of course, because it's going to be 21. So same answer as before. When we did these before, I just talked about how to write them. I am writing more than you need to do because I'm lecturing. I can leave out the y times 100 is 2,100, and you can still follow exactly what's happening. I can leave out my little orange divided by 100s, and you can still know exactly what I'm doing. If I left out both of them, then I'm not quite sure how we were getting from here to here. I can guess because we both know how to do the problem, but that counts as too big a step. Whoever is grading you wouldn't know exactly what you did. If you are going into Math 60, your Math 60 instructor should start the term writing as much as I do in this class, or in Math 20, but then as the term goes on, they will start dropping what I do in orange. This is just sort of implied on the board. So once you are trained to see that, then they will stop writing that. If that's not how a Math 60 instructor does things, and they either don't put it on in the beginning or don't eventually drop it, then talk to them and say, you need to start earlier like Math 20 and finish later like Math 65.
Yeah, that really helps having all the steps explained. I didn't really break it down at all.
The other thing is that there was the shortcut. Let's multiply the two that are opposite each other, the 60 and 35, and then divide by the odd one out, the one that's opposite the letter. And you can do that shortcut if you're not going on to Math 60. And we talked about why last time we saw this. So this is more writing. Why is it more writing? Because this method has a riplop where you're doing scoots in your head. So this one has more writing. But if you like cross multiplying, there you go. This can make you happy. Let's do the others. Is it okay if I leave the other slide? Did everyone write what they needed to before I go on? Yes. Okay. So we're doing 12 is what percent of 5? So make a skeleton. On the right, have your percent. On the left, have what comes after of. On the top, what haven't you used yet? Everyone okay with my 4-step setup phase? This was 210, right? No, 240. I misremembered because of the 21 before. Okay. Questions about that one? I guess I should add that this looks a lot more like the previous one than the first two we did with Amanda and me. So some people like the proportion method just because it sort of always looks the same on the page, and that feels nice. Okay, last one. Everyone okay with this before I go on? I still see some writing. Okay. I don't want to rush you. So skeleton percent something after of something we haven't used yet. Here's a little detail I don't know if I've talked about yet. This true. How come I put the box around the 250 and not the whole y equals 250?
Because the answer is 250, not y equals.
Yeah. Paraphrasing, the y is just my own personal thing I made up while doing this. Someone else could have used x or z or whatever letter they wanted. My boss at work, who assigned me a problem, just wants to know something. 250 apples, or whatever this is. So that's my answer. The rest is just sort of my personal thoughts. Okay, there we go. 2 ways to solve these. Notice that percent sentences can shuffle around the order. We could say, y is what percent of z, what is y percent of z, y is what percent of z, y is z percent of what. Y and z are 2 different numbers. The what can be first or second or third. And we can shuffle them even more. Everything we've done so far today about this has had the is come before the of, because that's how most people's brains like this. But we could equally well, the way English works, rearrange them. If I said, what's 50% of 12, that's the same as 50% of 12 is what? It's just that for most people, the second sounds funny. Or if I said, 30 is what percent of 100, that's the same as what percent of 100 is 30. And if I said, 99 is 2% of what? That's the same as 2% of what is 99. So the reason that these tools work, the translate and the proportion, is that even if someone writes it in the funky arrangement, everything will still work. You can still say what comes after the of, put it there on the proportion, or translate things just below where they are. Okay, before we started this, you had a third way with an acronym of power. Does that work for everything?
Yeah, it's a shortcut, so if you're okay with that, it helps your life to remember. It takes 30 seconds.
Sure. So I'm going to make a new thing and paste up this and get rid of that. Okay, there
This
you
was
go.
taught to me when I was tutoring GED students, so it works on the GED test, it works in life. You make a pyramid, and I've altered it a little bit, so you can remember P, W, R, and I told people it's power, P-O-W-E-R. You just leave out the O and the E, or P, B, R, the beer. So what it is P is power, or excuse me, part. W is whole. R is rate. Base is B. So multiplication is easier than division, so division goes on top. Okay, so any problem you got, give me a problem. 35%, so the percent is rate, like interest rates. So it is 35, and the other one is 60, which is the whole. So it's 60 times 0.35. If it was a part, 35 is what percent of 60, then part.
Well, let's do 12 is what percent of 5? Do the ones that are actually up there.
Okay, 12 is what percent of 5? So 5 is your part. 12 is your whole. And it says divide them because right here. Part divided by base equals, what was it, 2.4?
Except 5/12 isn't 2.4. So
Oh, sorry, 12.
What just happened?
What just happened? Part divided by base. Part divided by base. 12 is what percent of 5? Oh, 12 is a part.
Yes.
Sorry. So 12 is a part. Even though it's bigger, it's not the base. The base number is 5. That's what you're working with.
5 is our kind of reference number, our basis for comparison.
Yeah, so it'd be that one. Thank you. Does that make sense to anybody? My handwriting's horrible, my presentation's horrible, but this system works. You only have to remember PBR or power.
Thank you. So the reason I don't do this one is that thing that just happened. In so many real-life problems, parts are small, holes are bigger. But in the situations where that's not true, then it's easy on a test to forget which is part and which is whole and not notice that. So, but yes, this is a good thing. Okay, now let's move on. So we talked about using percent sentences to solve word problems that actually had paragraphs. Let's do this. A young couple earns money by improving a fixer-upper home. They buy it. I don't know why it says it, the home. They buy the home for $65,000. After months of repairs and improvements, they sell it for $105,000. A friend then asks them what was the percent increase. So, what is our percent sentence, right? What is of and percent that's in this situation?
Percentage, right? Of, no. Is.
We can always have something is something of something.
65,000 is what percent of 105,000?
Almost backwards. The 105,000 is what percent of the 65? So this is the same issue we just had, and again, Edwin's debt for the segue, that our basis for comparison what people think of as the whole is this number, and the number being compared what people think of as the part is on that side. This is always the percent. So if there's a change, then this is your original one. The price before something went on sale, or the price before it was increased with inflation, or in this case, home improvements, or so on. This is your weight before you went on the diet, this is the weight after. This is your weight before Thanksgiving and Christmas, and this is your weight in January you're less happy with, or something like that. And this is your original, this is your new one. So that's the Mad Lib's secret to doing this kind of thing. Okay, then let's actually do it. So I'll just translate, because that's easiest for me with what's on the board already. Is becomes equals, what becomes y, of becomes times. I have something stuck on with times, so I need to divide. So So it's worth 161% of what it originally was.
I moved my decimal wrong. Possibly could you do cross multiply?
Sure, let's do the cross multiplying. No problem. So, oops, can I not grab that? Yes. So, skeleton, the percent, the thing that comes after of,
What's left?
and whatever's left. That's going to be rounded, isn't it? And we'll get the same answer we did before, 1.61. Now, for this method, there's no riplop, so we're just going to get 161 after we do the division, and we just slam a percent sign on there. Yes?
If it's more complicated, so let's say that the 65 number, we had to add up 30 and 35 to get to that number. What's the best way to show our work? Do it separate or put it in parentheses?
The step that we did of taking a paragraph and making it into a percent sentence, you would have to have done something first, because we only get two numbers and the what. So if you have three numbers, you're not ready to translate it into a percent sentence yet. Okay, everyone good with this? Do you want this slide back? Okay. Here is a cute trick. When you multiply two numbers, it doesn't matter which order you multiply them in. And if you riplop, you're just scooting the decimal point. It doesn't really matter what you're scooting it on, as long as the scoots happen. So, if you want to say, what is 4% of 50, that might seem hard to do in your head. But you can pretend that the percent is on the other number. Instead ask, what is 50% of 4? So what's half of 4? 2. Ta-da. That's it. So what is 24% of 25? That seems confusing. But put the percent on the other number. What is 25%? So a quarter of 24. 6. Ta-da. A computer that normally costs $900 is on sale for 8% off. So how much is it on sale for? So what's 8% of 900? That might be a little tricky. Maybe not. But even easier would be, what is 900% of 8? 9 times 8 is 72. We're done. Okay, we have 10 minutes left. We'll actually get to start talking about the 3 formulas I mentioned in the beginning. We're going to start just by what is interest. Interest is a fee that the lender charges the borrower. If you have a savings account, if you've bought a government bond, you are the one loaning money. So you get the interest. Or if you have a credit card, then you are borrowing the money, so you pay the interest. Either way. The initial amount of the loan is called the principal. We already saw that with mortgages, how that word was used. So the loan with the least math, you would borrow money for exactly a year, and at the end of the year you'd pay back your loan, and you'd pay back the interest fee. So a $100 loan has a 1-year time, 12% interest rate. So we'd say, there's 0.12 times 100. If it wasn't immediately obvious where I got that, we would back up. We'd ask, what is 12%? Of 100, and then translate or proportions or things like that. Yes, question?
Since it's asking the total amount paid when you do it.
Yes, I will get to that in a moment. Good segue. Thank you. Okay, everyone okay with this very simplest case? If you do a bunch of these, you will see that what is 12% of 100 in that kind of format, some percent of a number, I'm just multiplying them together. If you're not quite there yet, then just translate it into a percent sentence. Okay, it can be easier, the 1 plus trick. So when we calculated that, the principal disappeared. We had to add it back in at the end. So we mentioned this 1 plus trick before, that if you add 1 in front, make it 1.12, then this times 1 will keep the 100 around, and you would get the 112 in what I'm calling 1 step. It's really 2 steps, because I'm putting a number 1 in front of the 0.12. But it's so easy to put a 1 in front of a decimal that it seems like 1 step. Yay.
That's what I was, that's what I
Yeah, this is easier. There's no virtue to doing it the long way, except that I'm starting slow. Okay, so if I want to do that again, I can say there's a $1,000 loan. It has an 8% annual interest rate, but I'm not going to multiply it by 0.08, I'm going to multiply it by 1.08. Okay, in real life, loans don't last exactly a year every time. That would just be too easy. So we need to get working our way up. If you had several years, and still the only payment happened at the end, then we would have several years' worth of interest. So 5 years and 12%. First we'd find the interest, just like before. Then we'd say $12 times 5 is 60, because each year we had our fee. Then we have to put on the principal. And we get 160 total. Okay, that's not terribly realistic. There are a few things, like treasury bonds, that work like this. And at the end of a long time period, you get your interest rate for every year, and then add on the principal, and that's what you get back. But most things in life, the fee doesn't just sort of pop into existence at the very end. Instead, each year's interest builds on the other one. Or in the case of your credit card, each month's interest builds on the other one, or however it is. So let's keep going and make this a little bit more complicated and then run out of time. The loans that do have the fee always stay the same. It's just based on the principal, like the treasury bonds. Every year, $12 was added on. That's called simple interest. And notice this isn't a math decision. It's a type of loan, like a treasury bond. It's convenient to work with. If we wanted to do a monthly kind of thing, we could just divide by 12. So if every year we had that 100 times 0.12 is $12, then we could say each month we'll pay back 1. That's not a big problem at all. And notice if we were to start with this and try and find an annual amount, the times 12 would get us back where we started. It's kind of stupid to do. Because of that, it's nice that if we had a time period that, why is that 36? That's too nice. Hold on. That's longer, we can just turn it into years. It doesn't matter how it's written, or even if it's a whole number of years, decimals are fine. Then we can just say that we have the 2000, and we're going to multiply it by 36 months, so that's 3 years, times that 0.05. So we have $300 of interest. 100 for each year. How much we'd pay back at the end, we'd have to add on the 2000 again. I'm skipping that. So this kind of setup we can write as a formula. And that's where we'll stop. So the simple interest formula is you take your principal, you multiply it by the annual interest rate, so that's like your $12 a year, and then multiply it by how many years that happens, like the 5 years we had for the bond up above. And that's how much interest you get. If you wanted the total amount paid back, you'd have to add back on the principal, because this formula loses the principal as you're working. Traditionally, this is written in a slightly more confusing way with just letters. I equals P times R times T. And that's great. If you've memorized this, keep doing what you know. But just pay attention that the I is simple interest. When we learn about other kinds of interest on Thursday, then they will have an I also. Oh well. Annual interest rate. If the rate was given to you in a monthly amount or something, you'd have to fix it. That almost never happens. For reasons we'll talk about soon, everyone changes interest rates to annual amounts, even when it's something like a credit card interest rate that has monthly payments. So you almost never have to fuss with the rate. The time measured in years, that's the tricky part. So if it was 6 months, this would be 0.5, you're at half a year. If it was 18 months, this would be 1.5, you're at 1.5 years, and so on. So if you haven't memorized I equals P times R times T, this is a little less of a trap because it actually says years in the formula. So you don't have to remember that the T is always years. Okay. But formulas are nice. So I'm going to space it out when I write it so I can line everything up. Remember when I'm doing my RipLop to have a 0 before the 4 if I need it. And 9 months, so 9/12ths. I don't even need the I there really. Okay, 3,500, 0.45 times 0. So, ta-da, simple interest is pretty friendly. Again, the only trap is to make the time always years. And that's a great place to stop for 2 days. Any questions before I say run away? We're out of time.
Just curious. The reason they do a yearly interest rate does have to do with federal regulations?
It's so you can compare things. So when you go shopping for ice cream at the grocery store, you may have noticed that the big tubs are listed in dollars per gallon, and the little expensive Ben & Jerry's and other Haagen-Dazs and stuff are dollars per pint and so on. So it's hard to compare and see which is actually the cheapest ice cream or by how much. So if this bank did a monthly interest rate and this bank did an annual interest rate and so on, then it would just be harder to compare.
That makes sense.
So if everyone does an annual interest rate regardless of the actual payouts, then you can say, yes, this bank has a better rate. And I'm slightly lying to you. We'll go into the details later.